Okay, so this is going to be the last section for chapter 4, and this is just going to be solving exponentials and logs. So a general rule of thumb, like I said, is if something's in exponential form, put it in log form, and vice versa, because it may be pretty simple to solve. Now, let's start out with a simple problem. Exponential. Okay, it's in exponential form, we can't solve for x. But if we put it in log form, you can see that we have solved for x. Okay, so I'm assuming that on these, I'm going to go ahead and just show you the answer, but this is how you put it in the calculator. You go ahead and do the change of base like we talked about last time, and you get the answer. Okay? 3 decimal places, hold on a second. 12 divided by 7. Well, let's say it's approximately 1.277, 3 decimal places. Okay? Let's look at this one. E to the x squared equals 200. Okay, another exponential. If we put it in log form, this is going to be log, natural log, base e, of 200 equals x squared. Then to solve for x, we take square root of both sides. So x is the square root of natural log of 200, which we put that in the calculator, and we get approximately 2.302. Okay, that's another exponential. Let's look at another type of exponential. Say we have e to the 2x plus 1 times e to the negative 4x equals 3e. Okay? What we need to do is we need to get it down to a single log before we can convert it, a single exponential before we put it in log form. So let's combine all these down to a single log, a single exponential. So to combine these first two here, since they're multiplied together, we add them. So it's going to be e to the 2x plus 1 plus negative 4x, which is e to the negative 2x plus 1, equals 3e. Then, if we divide both sides by e, that would be like e to the first power, and we subtract to combine those, so we have e to the negative 2x equal 3. Okay? Now it's a single log, so over here we convert it to, a single exponential. We can convert it to log form. It's going to be natural log of 3 equals negative 2x. Then we divide by negative 2. X is the natural log of 3 divided by negative 2. And so if we do that in the calculator, we get negative 0.549. Okay. Now let's look at another exponential one. This is going to be a little bit more complicated. 3 to the 2x minus 1 equals 4 to the x plus 2. Okay? When we go to solve that, there's no way to write those with the same base. We can't write 3 and 4 with the same base like we've done before. We have to have some other way to do this. Now, there's a lot of different tricks you can do. The first thing I like to do is go ahead and just take the natural log of both sides. Take the natural log of both sides, then start doing some of our log properties. We can take exponents and write them as a lead coefficient. Okay, and then let's go ahead and distribute our natural logs. We get 2x natural log of 3 minus the natural log of 3 equals x natural log of 4 plus 2 natural log of 4. Now you can see we have some terms that have x in it, which is what we're trying to solve for, and then some terms that don't have x. Okay, so what I'm going to do is I'm going to put everything with an x on one side and everything else on the other. So I'm going to leave the 2x natural log of 3 over here. I'm going to subtract the x natural log of 4 from the other side over here. And then I'm going to go ahead and add that natural log of 3 to the other side. Okay? I'm going to skip to a new page. So I have 2x natural log of 3 minus x natural log of 4 equals the natural log of 3 plus 2 natural log of 4. And then here you can see I can factor out an x, which leaves me 2 natural log of 3 minus the natural log of 4. Divide by all of that, this guy, to solve for x. And we get natural log of 3 plus 2 natural log of 4, all divided by 2 natural log of 3 minus the natural log of 4, which is approximately 4.774. Now that is a lot trickier than the other one we did. The trick was, when we start here, if we cannot write these numbers to be the same base, start by taking the natural log of both sides. And that could be any natural log. You could do natural log, log base 10, whatever. And this is how you do it. And then just start following your log properties to solve it from there. Okay, let's solve some log problems. So you have log base 10 of x plus 6 minus log base 10 of x plus 2 equals log of x. Okay, we can write this as a single log and then convert it to exponential form. So we first got to combine all of our logs down. First, we can combine these two if they're subtracted by dividing. That's going to be log base 10 of x plus 6 divided by x plus 2 equals log of x. And then, because these are the same base, log base 10, I can just literally just drop the logs and say x plus 6 over x plus 2 equals x. And then from there it actually turns into a quadratic. We get x plus 6 equals x times x plus 2. X plus 6 equals x squared plus 2x, which gives me x squared plus x minus 6 equals 0. Factor it, x plus 3, x minus 2. So we get x equal to negative 3 and positive 2. Okay, now what we have to do, since we have a log, we got to make sure and see if this fits. Okay, we cannot take a log of a negative number because that don't make any sense. Can we, like when we look at a graph, our graphs look like that. This line on the left hand side never goes past the x-axis, so they never can be negative. So that's an exponential graph. So you know that on log, you can never take a log of a negative number because the exponential can never be negative. Okay? So we need to look at our answers and see if any of those give us negative answers. Right away, if you plug in negative 3, there's a negative log, so we have to throw it out. Okay? 2, does 2 work? If we put it in here, and we'll choose blue here, that's a positive number, that's a positive number, that's a positive number. So x equal to 2 is our only solution. Okay, let's do another example. Log of 3x plus 2 plus log of x minus 1 equals 1. Combine them together by multiplying. 3x plus 2 times x minus 1 equals 1. Convert it to exponential form. That's 10 to the first power equals 3x plus 2 times x minus 1. I'm going to multiply all that together and combine them down. I'm going to skip a few steps here. I get 3x squared minus x minus 12 equals 0. And if we use the quadratic formula with a equal to 3, b equal to -1, and c equal to -12, we get two solutions. I'm assuming you know how to do the quadratic formula. Again, we get 1 plus or minus the square root of 145 over 6. Okay, if you're unsure what that is, 1 plus the square root of 145 over 6 is approximately approximately 2.7, or excuse me, 2.174, and 1 minus the square root of 145 over 6 is approximately negative 1.84. So we look back at our original problem. Which one of those is going to give me a negative answer? Which one will be a positive answer? If we look back, we see that this one we have to throw out because it's going to be a negative. It's going to be negative here and here. So the only one we can accept is the positive one. So that's our only answer. So we can say x is 1 plus the square root of 145 over 6. Okay, so there's how to solve some of those. Look for the homework coming up soon for this chapter.